For numbers 15, 16, and 17, we're going to simplify square root problems that have fractions. So when you look at the square root on the bottom part of a fraction, so you have a square root in the denominator, first thing I always check is 11 a perfect square that I could just move to the outside? And it's not. 11 is not a perfect square. So the next thing I check is, well, does 11 divide evenly into the number on top in the numerator? And 11 does divide evenly into 22. It divides into 22 two times. So I could just reduce this fraction. So the 11 makes the 22 turn into a 2. Now it's over 1, but there's no point in me even writing the 1. Everything has an understood 1 on the bottom. I do still have this x to the 7th though. Okay, so all I've done is reduced 22 over 11 to 2 over 1, and I just didn't write the 1 on the bottom. So that could be my final answer, but before I determine that, I have to look at what's left under this square root sign, and if there are any perfect square factors that could move to the outside, they need to move out. So when I look at this 2 can only break down to 1 times 2. Now 1 is a perfect square, but it makes no difference if you move it to the outside, so that doesn't really count. 2 is not a perfect square, so this 2 is just going to stay under here. It's just part of my answer under the square root sign. But when I see this x to the power of 7, now it's an odd power, so right now it can't move out, but I could break 1 away from that. So I turn my x to the 7th into a 6 and 1. Because this even number of x's could move to the outside and cut in half. So when I take the x to the 6 to the outside, it turns into x to the 3rd. This 2 and this x stay on the inside. So one of the things to remember when you have square roots with fractions, you can't have a square root on the bottom side of a fraction. Now I don't even have a fraction left on this one, so I know that this one is fine. Look at number 16. Again, the first thing I always check is, if there's a number under the square root on the bottom side of the fraction, is it a perfect square that I could just take out of the square root sign? Is 49 a perfect square? Yeah. What's the square root of 49? 7. So now, see how this square root sign goes all the way down to the bottom? I can take the square root of 49. It's 7. I still have this stuff up top under the square root sign, 50x to the 3rd. Make sure that this doesn't dip down so that it looks like the 7 is under the square root sign. You moved this totally out. It is no longer under a square root sign. So now I just have to look at this top stuff and see, are there perfect square factors that could move out? So you guys know that 50 is 1 times 50, 2 times 25, 5 times 10. Can you pick out any perfect square factors to move out? I hope you picked out this set right here because 25 is a perfect square. So I'm going to trade my 50 in for a 2 times 25. And the 25 is what's going to move out. This x to the 3rd, I'm going to bump 1 away so that the even part can move out. Don't forget about that 7 that's still under there. Move out the ones that you've underlined. The square root of 25 is 5. The square root of x to the 2nd is x to the 1st. You can write it, you don't have to. Inside you have a 2 and an x. And down below you still have this 7. Now what I would check is this 5, that's a number that's outside the square root, and this 7, that's an outside number. If those two reduced, like if this was a 5 and a 10, I would reduce them. But they don't reduce. My answer is good because this bottom number is not under a square root sign. Nothing moves out of this, so I'm done. That's my answer.